Welcome back, everyone. If you've ever stopped and wondered exactly how scientists actually prove that one thing causes another, well, you're in exactly the right place. Today in this explainer, we're going to literally unlock the secret code of scientific investigations. We're going to demystify how researchers from multi-million-dollar laboratories to students in a backyard garden design their experiments using three simple but super powerful concepts: cause, effect, and fairness. By the end of our time together, you'll be able to look at the world completely differently, easily spotting the invisible variables that shape every single scientific test.
Okay, so here's our roadmap for today. First, we'll cover the building blocks of science. Then we'll dive into the independent variable, the cause. Next up is the dependent variable, the effect. After that, we'll look at controlled variables to keep things fair, and finally, we'll put your knowledge to the test.
All right, let's jump straight into Section 1, the building blocks of science.
Every great experiment, whether we're talking about a high-tech lab studying medicine or you just trying to grow the perfect tomato plant in your backyard, relies on our very first building block, the independent variable. By definition, this is the factor that the investigator changes on purpose. It's the root cause, the test factor. If you're ever trying to find the independent variable, just look for the exact thing the scientist is actively altering or deciding to make different.
Let's bring this to life with a scenario from the Philippines. Say a student asks, does the amount of sunlight affect the growth of mungo seedlings? Picture three pots set up next to each other. One gets just a little sunlight, the middle one gets some sunlight, and the third gets a lot of sunlight. The helpful tip to remember here is to always ask yourself, what did I change? Well, the student changed the sunlight on purpose just to see what would happen. Therefore, the amount of sunlight is our independent variable. It's the cause we're testing.
Moving right along to Section 2, the dependent variable, also known as the effect. To make this super easy to remember, let's draw a really sharp contrast. The independent variable is what you, the investigator, change on purpose. The dependent variable, on the other hand, that's what is observed or measured. Think of it as a very strict relationship. The cause is what you actively control, and the effect is what you sit back and watch happen as a direct result. Let's lock in that dictionary definition real quick. The dependent variable is the result that changes because of the independent variable. Honestly, the name itself gives the whole game away. Its outcome completely depends on what you did first. It's always that specific thing you're observing or taking a measurement of, maybe with a ruler, a stopwatch, or a scale. So, how do we actually quantify those results? Going back to our mungo seedlings, let's say after 5 days, the student takes out a ruler. The seedling with little sunlight is 4 centimeters tall. The one with some sunlight is 6 centimeters tall, and the one soaking up all the extra sunlight, 8 centimeters tall. Now, if we ask our tip question, what did I measure or observe? The answer is the height of the mungo seedlings. Because the height depends on the sunlight, height is absolutely our dependent variable.
All right, Section 3, Controlled Variables. This is all about keeping things fair.
Listen, without this next step, any scientific investigation totally falls apart. Controlled variables are the factors that you keep exactly the same in all of your setups. Why? So the test is completely fair. I mean, think about it. If you change more than one thing at a time, you're never going to truly know which change caused your final result. Controlled variables ensure that only your independent variable, your purposeful change, is what's affecting the dependent variable.
Let's use our mungo plants one last time to visually prove this. To make absolutely sure the test is fair, you have to look at what the student kept identical across all three setups. They used the exact same pot size, they used the same kind of soil, they poured the same amount of water, and planted the same number of seeds. If they had used a bigger pot, or maybe accidentally drowned one plant with extra water, and hey, we've all been there, those hidden factors might have actually caused the 8-centimeter growth rather than the sunlight. By keeping everything else identical, you guarantee a fair test.
So here's a crucial mental checklist I want you to lock in. Step 1, ask, what did I change? That's your independent variable. Step 2, ask, what did I measure? That's your dependent variable. And step 3, ask, what must stay the same? Those are your controlled variables. You're going to want to keep this checklist handy because we are just about to use it. Which brings us to Section 5, put your knowledge to the test. All right, here is our first interactive challenge. Let's see if you can identify the cause, the independent variable, in 2 brand new scenarios taking place out in Laguna and Cebu. First up, in Laguna, Anna is testing whether different amounts of sunlight affect pechay growth. She places pots in shady, partly sunny, and fully sunny spots. So what is her independent variable?
Meanwhile, over in a science class in Cebu, Carlo is comparing 3 different paper towel brands from a sari-sari store. Brand A, B, and C. He's dipping them in water to find out which one absorbs more. What is Carlo's independent variable? Take just a second, pause if you need to, and make your guess based on what we've learned. Just remember to ask, what did they change on purpose?
And the answers are in. For Anna in Laguna, it's A, the amount of sunlight. That is exactly what she changed across her 3 pots. And for Carlo in Cebu, the answer is A, the paper towel brand. He deliberately chose different brands to test. If you got those right, huge congratulations. You are successfully spotting the intentional changes scientists make every day.
Let's challenge ourselves again. This time, we're traveling over to Davao and Baguio, and we're hunting for the effect. What is the dependent variable? What's actually being observed or measured as the final result?
Okay, so in a school in Davao, students are testing whether different fertilizer types affect tomato growth. After 2 weeks, they literally measure the height of each plant. What is their dependent variable? Is it the plant height, the fertilizer type, the pot size, or the amount of water? Now check out Baguio. A grade 7 class is testing whether ice melts faster in a metal cup or a plastic cup. They're using a stopwatch to record the time it takes for the ice to completely melt. What's their dependent variable here? The time, the cup material, the ice cubes, or the location? Take a moment to think it over.
All right, the answers are, in Davos, it's A, the plant height after 2 weeks. That's the final measurement they actually recorded. In Baguio, it's also A, the time for the ice to melt. That stopwatch gave them their dependent variable data. This beautifully reinforces the idea that things like height in centimeters and time in minutes are concrete, observable measurements that depend entirely on how you set up the experiment.
Okay, we've got one final challenge for you today. We're heading out to Iloilo and Quezon City, and this time our goal is absolute fairness. Let's find those controlled variables.
In Iloilo, learners are testing whether the amount of water affects mungo growth. Now, since they're already changing the water, which of the following should be controlled variables to keep the test perfectly fair? Pot size and soil type, plant height, amount of water given, or number of leaves? And in Quezon City, students are testing which dishwashing liquid removes grease the best. Which set here shows controlled variables? Same sponge size and plate type, different soap brands, amount of foam, or the students' opinions? Go ahead and lock in those final choices. And here are your final answers. In Iloilo, to keep that water test completely fair, you have to control A, the pot size, and the soil type. You absolutely must keep them identical. And in Quezon City, to fairly test those dishwashing liquids, the answer is A, the same sponge size and plate type. Imagine if one plate was way greasier or one sponge was a lot rougher, the whole test would be totally ruined. Great job keeping that playing field perfectly level.
Wow, we've covered a lot of ground today, haven't we? From mungo seeds and sunlight to paper towels and melting ice. By wrapping your head around independent, dependent, and controlled variables, you literally now have the exact blueprint that scientists use to uncover the truth about our world. So I want to leave you with this bit of a provocative thought. Look around your home right now. Is it the type of coffee you brew, or maybe the brand of batteries you put in your remote? What experiment can you design today using the rules of cause, effect, and fairness? Because honestly, the world is your laboratory. You just have to know how to measure it. Thank you so much for joining me on this explainer. And remember, keep questioning everything.